our next speaker is Indhu Varatharajan from the Department of Geosciences, and she will be presenting on recreating the surface of planet Mercury on Earth.
Thank you. Mercury, the closest planet to the Sun, the hottest planet with no atmosphere, and is the least explored inner solar system object. Why do we have to care about Mercury? Why do we explore Mercury? If we ask scientists of different disciplines, they may say different answer. For example, Professor Albert Einstein would say, the general theory of relativity is completely inspired from the strange orbit of Mercury around the Sun. Why do I care about Mercury? How Mercury fascinates me till today? The answer lies in the volatile rich interior. Being formed so close to the Sun, Mercury must have lost all of its volatiles to the Sun's temperature. On the other hand, we see evidences of explosive volcanism like Mount St. Helens on the surface of Mercury. The another set of strange and unique features to Mercury are sublimation pits. From now onwards, we will remember them as hollows. These pits, they say it forms when certain type of material came to the surface and then they disappeared into thin air. How can that happen? Scientists came with the hypothesis that when pockets of volatiles including sulfur, when they interact with magnesium and calcium rich molten lava, they form magnesium sulfides and calcium sulfides. And these sulfides find their way to the surface through the cracks and float in the form of slags. But the surface is really hot and the sun is beaming at them. So the sulfur escapes, collapsing the slag, forming hollows and sublimation pits. So shall we test this hypothesis together? So to do that, we have to recreate the surface of planet Mercury. So let's go to Germany. There is a Mercury chamber sitting at Planetary Spectroscopy Laboratory in German Aerospace Center. This chamber works very similar to the induction stove we have in our home. So we keep the sample on a ceramic plate and we heat the sample through induction coil. As we heat, the heat emanated from the sample is sent to a spectrometer. That spectrometer collects a type of data which directly mimics a type of data we collect from the satellite orbiting Mercury. The coolest thing about this chamber is the hottest temperatures that it can reach to. These chambers can heat the samples up to 900 degrees Fahrenheit, that is 500 degrees Celsius. And the entire chamber works in complete vacuum, means no air. So mimicking the surface of planet Mercury on its hottest day. So to test, let's take magnesium sulfide, put it inside the chamber and heat them slowly. We see the sulfur escaping, carrying dust and depositing material all around the chamber and in and around the sample cup. We see the sample is destabilizing, gaining energy from the heat, showing the sample cup itself, completely mimicking the formation of hollows, even may mimic the explosive events on Mercury. Now we know magnesium sulfide is really unstable on Mercury and can lead to formation of hollows. What about calcium sulfide? We heated them up to 500 degrees Celsius, nothing happened to the sample. Even the spectral data we collected from that show no such differences with change in temperatures to calcium sulfide. So we further investigated different types of sulfides of various other metal ions. And what we learned that mostly all of the sulfides other than calcium sulfide change in its spectral behavior or the behavior of the material itself when it is exposed to extreme mercury thermal environment. So the study which I did, the spectral study which I did, had direct implications on the data we collected from NASA Messenger mission. NASA Messenger mission now shows that there are sulfides in and around hollows and pyroclastic vents on Mercury. These hollows are distributed all across the Mercury over different temperature zones. So it is very important to know what is the nature of these hollows across the Mercury to know how deep the material is coming from inside of Mercury to the surface. That's why the Bepi-Colombo mission, which is on its way to Mercury and will reach Mercury in 2025, will tell us the nature of hollows, the abundance of hollows, and will Mercury explode now? We will know in 3 years. Thank you.